By the end of this video, you'll have a system where the coins will travel to its UI target dynamically. Like even when you change its position, it still works. And this works in both perspective and orthographic views, and also in all the render modes. All this with only a few lines of code. So if you're interested, keep watching. I've created a simple scene here, and the UI canvas has a coins container, which will be the target for all the coins to travel to. And similarly, we have a coin spawner, which spawns the coins and also act as the starting position for them. And we have a crate, which is simply a visual element, and also a coin. This is what we are going to be spawning later. You could turn this into a prefab if you want, but I'm going to leave it be a simple game object in the scene. And in the coin spawner, I have assigned the coin object and coins container. We have one more field called tween settings. This is part of the prime tween library. It is similar to do tween and lean tween. I'm using prime tween to move my coin from point A to point B. And this is the settings. And inside this, I can set how long it would take for the tween to complete, and what kind of easing do I want, and stuff like that. Let's have a look at the script. And also, I've attached a rotate script to the coin itself that simply rotates its transform in the y-axis at this speed. All right, back to the coin spawner. We already went through all the serialized fields, and then we have a on pointer click method. This is part of the I pointer click handler interface, which is part of the Unity Engine event systems library. What this does is, if this game object has some kind of collider and we click on this game object, it is going to call this method. And when this method is called, we are first creating two vector threes. One is called start position and another one called end position. And for the start position, we are simply going to set our coin spawner's transform position. And for the end position, I've created a simple method that returns a vector 3 called get target position. And inside this, for now, I'm simply going to return the word position of coin UI. Once we get that end position, we are going to spawn a new coin object at start position. And using the prime tween library, I'm going to move the coin from its position to end position with the settings we saw earlier. And inside that settings, it had like 1 second duration, right? So basically it takes 1 second for this coin to travel from starting position to end position. And once the tween is completed, I'm going to destroy the coin. And then I've used on draw gizmos to draw a yellow line between start position and end position, which is going to make it super easy to visualize the path. And back in Unity, if you want to see the gizmos, I mean, you can already see it in the scene view, but if you want to see that in the game view, just maximize this and enable the gizmos. And you can see it in the game view as well. Let's try clicking on the coin spawner. And it looks like the coin is getting bigger as it travels to the UI, right? But that is not the case. Let me zoom out. And yeah, let's try spawning now. As you can see, the coin actually stays consistent with its scale or size, but it is traveling near the camera. And this is where the camera is, right? So since we are in the projection view, it appears like it's getting bigger, which is a problem. But if I change this perspective to orthographic projection, it looks all right. This is what we are trying to get, right? But this is not a solution for our problem. We need to come up with a better solution. For this, what I'm going to do is I'm going to get the screen space coordinates for this UI element that will be X and Y, right? And the screen space coordinates are in pixels. So if I'm targeting somewhere around here, the X and Y values will be 0 for X and 0 for Y, because this is the starting point. And if I go around here in this corner, it would be like maximum for the X, however, 0 for the Y. And if I go to this corner, it will be 0 for x, but maximum value for the y. And here it will be maximum value for x and y. You get the idea where this is going, right? But we can't use that. We can't use pixels for, we need a word coordinate. So I'm going to get the distance of our camera from the origin point and add it to this vector 3's z value. Once that is done, I'm going to convert it to the word space, and we should get somewhere around here. Like when you're looking at the scene view, the line should end somewhere abruptly, but if you look at the game view, it should make sense. So let's have a look. I'm going to create a new vector 3 called screen position, and using camera.main, we can get that value. However, I'm going to create a new serialized field for our camera first. Now using that camera, I'm going to get word to screen point, and I need to pass in a position. That would be our coin UI dot position. Now we get the x and y coordinates. So I'm going to call screen position dot z and set it to the camera dot transform dot position dot z. And after doing that, I can create one more vector 3 called word position and call camera dot screen to word point and pass in our screen coordinates. That is the screen position. And I can return this here. We need to assign the camera to this camera field. And as you can see, as we predicted, the line ends up apparently nowhere in the scene view, but you can see that it is working in the game view. Let's try playing this, and it looks fine. Even when I rotate my camera, that should update accordingly. And if it does the same thing when I change the UI's position. But there's one problem now. Right now, the camera's Z position is in positive range, right? It is plus 22 point blah blah whatever. So let me try making it a negative value. Watch this yellow line in the game view, not the scene view. As soon as I go to the negative value, that line disappears. So that is a problem because we are looking for the distance. Distance can never be negative value, right? So let's make sure that it is always a positive value. We can do that using mathf dot absolute or ABS, and it takes in a float and it returns. It makes sure that float is always positive. Now, even when the Z is a negative value, the line is still visible, right? So that's great. And it works in the orthographic mode as well. Now, what if I switch the render mode to word space? Well, it works. Okay, it works in word space and screen space. These three lines will work for both those spaces. However, if I switch to screen space overlay though, it breaks. It's not working anymore. So we need to come up with a different solution for this. Okay, let me change to the screen space overlay. So what I'm going to do is I'm going to create a plane at this UI's position, and I'm going to project a raycast from my camera to that UI position to this plane and return the point of intersection. I'm going to comment these three lines. Now I can do this step by step, or I can use a helper method that Unity provides. This helper method is inside a class called rect transform utility, and the method is called screen point to word point in rectangle. This takes in a rect transform. We already have a reference to that our coin UI's rect transform, so let's pass that. And it takes in a screen point. We are looking for our coin UI's position, right? So let's pass that. And then it takes in a camera. We already have a reference to our main camera, so I'm going to pass that. And then it needs a out vector 3. So out keyword means we are passing a reference, not a value. So whatever modifications we do to this vector 3 inside this helper method will retain even when we come out of that scope. So for this, it needs a vector 3, right? So I'm going to create a vector 3 called world position and pass that here. I think I made a typo here, so I'm simply going to copy and paste that here. All right, cool. Let's have a look at this method, what this is doing, right? Here we can see that we are initializing our word point with the vector 2.0, and then we are going to create a ray that goes from camera to the screen point. Then we create a plane at the rect transforms position, and these lines, what they're doing is they're simply going to check if the ray is intersecting with the plane, and if it does, it is going to return the distance. And then we are going to set our word point with the point of intersections. So here, this ray.getPoint takes in a distance. That is what we are passing here, and it will return the position where we are intersecting. And we are setting that to this out variable, right? So once we exit that function, we will have that point of intersection, and that is what we are going to be returning. All right, you can already see that it is working. But let me try entering the play mode, and this works in the perspective view. Let me try with the orthographic view, and it works in that view as well. So now we have come up with a solution to all three render modes and also the two projection views. To clean things up, I'm going to make it automated. Here, I'm going to pass a serialized field of type canvas, and I'm going to pass in the root canvas where we are going to change the projection type. And inside the get target position method, after defining a word position, I'm going to ask if root canvas dot render mode is equal to render mode dot screen space overlay. I'm going to perform this line of code, else I'm going to cut these three lines and paste it here and uncomment them. And I'm going to remove this. So first we are going to define a word position of vector 3, and if the render mode is screen space overlay, we are going to perform these calculations, and if it is the other two types of render modes, we are going to perform these calculations, and then finally we are going to return the word position. We need to assign the root canvas to our field, and now if I press play, it works fine even when I switch the render modes, and it does the same thing when I switch to other projection modes. So this is great. Thank you for watching. In the next video, we are going to use Bezier curves to add some custom shape to the path. And if you're interested, make sure to subscribe and enable the bell notification so you'll be notified when that video is up. All right, see you then.